Well, I think we're live now. Hopefully everything's coming through just fine. Hi there, Lost Algorithm. Thanks for joining us. So yeah, it's been a while since Paul and I have streamed together.
It has been a hot minute.
Yeah, it has. So hopefully everything will come back in shape and order so we can start doing this again more regularly like we have in the past. Because I was going through all the videos on YouTube, kind of looking for something, and I was like, hey, we've actually streamed a lot together. It's pretty crazy.
Yeah, I guess we have done a fair bit.
And I have almost I think 120 subscribers now on YouTube alone under my namespace, because I keep pushing all these up into there.
Nice.
It seems that people actually want to watch these things. So yeah, I thought that was kind of cool.
I guess you're kind of a big deal.
You know, one day I'll get that 1 million subscriber YouTube thing behind me. You know, put it over there. That's the ultimate goal, right?
All right, Josh Wiseman wannabe.
There you go. Oh man.
All right, so let me just give you a quick update of where I'm at, because I may be disappearing and reappearing. 1 second, because I'm about to have a COVID sneeze.
Yeah. As he's coming back and going, I kind of want to tell you what we're planning on doing today. Oh, you're back now.
I am back. It was a quick COVID sneeze. I'm all good. Now, I think ragweed or something's going on here, so it's a bit rough. So I got a brand new machine. I started installing stuff on it and realized I didn't have time to get everything installed in time for this stream. So I don't even have my own stream running right now. So while you give an intro, I'm going to be trying to get all my audio hooked up so that I can actually hit stream on my new OBS on my new machine. So I will probably mute myself, and if you want to just go ahead and do the talkie.
Yep, perfect. So yeah, today's plan is I've been searching high and low and for some type of tutorial or some type of walkthrough of how to build your own CA. Now, all of a sudden, if you don't know what a CA is, it's something called a certificate authority. So when you connect to a website out there, you know, you have that little lock on the icon to be able to say that this is a secure connection to that website. Well, there's a bunch of certificate authorities out there, including Let's Encrypt and VeriSign and things like that all the major browsers accept as like, hey, you say that VeriSign says that you are who you are. We'll go ahead and agree that this is a secured connection back and forth. If you didn't know, you can run your own CA internally. So you can actually build the CA server, or it's actually just an application, and then you can put it on a different computer or whatever. And then you can take an Nginx pod or whatever, put that cert in there, and then from another machine, connect to it. And if you've imported the CA that you created's upstream cert into your key store, you will have a secured connection talking to that. If that seems convoluted, I'm sorry, but it's basically we're creating a third party to say that yes, the communication between you and Nginx on a random machine is secure, or is the same one saying you're expecting it to be. This is great for home labs if you ever need to work on using stuff with HTTPS or whatever, or for that matter, just being able to know how all this stuff kind of comes together. This is the biggest challenge is obviously your CA will very unlikely ever be given into the major browsers out there to say that yes, this CA is like one that can be taken from. But in theory, you could take if you exposed your CA to the internet, for instance, you could take that upstream cert, give it to your friends or whatever, to say that they can import it, and then you could export out some HTTP services or whatever, and it would be a secure connection between them and your service. So you could become your own little like cabal of secure communication through HTTP, which is, if you extrapolate that farther, all of a sudden becomes really cool because then you have a way to have your own kind of fiefdom, if you will. So what we're going to try to do is we're going to try to fake this whole thing out from the ground up. And from there, hopefully we'll learn a little bit more about how the keys work and all that. And I will say the largest challenge normally with this stuff is getting your CA's upstream cert into the different operating systems out there. To be able to say that like Mac will allow you, Mac has a different way than Linux that Windows has to say that this is how I take that upstream cert and say that this is the cert I accept. Now, and one last thought, not just home levers can do this. In theory, your company could do this too. So let's say, for instance, you have a internal intranet. You could, in theory, have pure HTTP communication, HTTPS communication using this upstream cert too. So there's a lot of, it opens up a lot of interesting doors, but you kind of have to go through the process to understand how to do it. And luckily, I found a pretty good, straightforward example, which I will copy this right now and put it into the chat. And hopefully I'll remember to put this also in the YouTube description later, which kind of walks you through the whole thing. So we're going to start there on the same machine that CZ and I always work on. We're going to build the CA from that, and then we're going to try to play around with some certs. Is that a good good explanation of our plan here, CZ?
Yeah, I think so. So I managed to get, yes, it is. I managed to get my stream going, and I think I have audio working. It's a bit kludgier than I usually do, but it is, I think, working. So we're all good on my end now. I may mess with my scenes as we go through, because hadn't set up any video capturing or anything on it. But yeah, your description sounds really good. I was going to say there are a number of tools that attempt to make creating certificates easier for you, but it's always good to sort of go back to kind of the root of the problem and look at it. Yeah, root. Yeah, get it. And kind of understand the process, even if you're not going to be manually doing the process. So usually on a Linux machine and maybe on a Mac, you would use OpenSSL as a command line utility to create certificates and whatnot, I believe is the tool you use. But there are tools like CFSSL, which I think is written in Go, and that's an attempt to make it easier for you to create certificates for applications to use and stuff. I actually, just before that came out, I wrote a thing called OMG WTF SSL, which basically was a Docker wrapper around the OpenSSL commands, and you would run it and you would give it some environment variables like the common name, DNS names, etc., and it would spit out certificates either to standard out or to a volume. And that actually briefly had some popularity, and it was rather amusing. I came across a GitLab issue where they were discussing the removing, oh my God, what the fuck, SSL from their CI system because it was unprofessional sounding. And I see that as a great success, that not only did somebody use it, but then somebody stopped using it because it has a stupid name. And then even more recently, when so Let's Encrypt came about, and Let's Encrypt is a consortium of folks that were like, we want to make certificates easy so that everyone can run a secure website. And so they run free TLS certificates, and they have a really good set of APIs and stuff around creating and allocating certificates. And so there's really no excuse for you not to have a real certificate on your publicly accessible things, but they don't necessarily help you with privately accessible things, because one of the things they need to do is verify that you own the domain that you have. So they do validation of either your domain name. So you have to prove via like text records in your DNS provider that you own the domain, or you have to put certain files into the web server hosted by that domain and that it will read and verify. Now, obviously, if you have a private website like an intranet, it won't be able to access that. So it won't be able to verify it. So it can't give you a certificate. So you still have that gap of what are you going to do for your private stuff? And that is exactly where I think JJ is going with wanting to do this. You could spend the $3 million and buy a like CA management suite of software and hardware tools, but you can also, fairly easily manage certificates. One of the cool things that came out with Let's Encrypt is there's a Kubernetes controller called Cert Manager, and that lets you create certificates quite easily with Let's Encrypt. But what's not super obvious and what people don't talk about as much is that you can also have it create regular certificates. And so if you want to do what JJ and I are going to do, but you want to do it without knowing all the like source commands, the root commands, you can actually use Cert Manager, and you can tell it to create a certificate of type CA, and then set that as a cluster, as an issuer, and have it then create certificates for you based on that CA. Yeah. So you'll get roughly what JJ and I are going to be doing, hopefully, if we succeed, but without all the manual work.
Nice. And there was one stretch goal. It might be better for our next stream if we decide if we do complete this. Another stretch goal that just kind of came to my mind from what CZ was just saying is it would be neat to create like a playbook or whatever that we could put our upstream cert into. So if you needed to inject that cert at build time of the server or whatever, you would have a programmatic way to do it. So in theory, back to that intranet or home lab or whatever, you would never have to actually think about injecting that cert into whatever OS you're spinning up to do the thing.
Right, you're talking about the root CA cert, right?
Yes.
Yeah. And did you, while I was getting my machine ready, did you talk about the difference between the keys and certs?
I just kind of gave up the grand overview, so and I put the link already in our chat or in my stream chat. Okay. Have you put it in yours, or do you want it? Or I'm just going to bring it up.
Just bring it up, and I'll figure it out from there.
Okay. All right. So hopefully everyone can see this now. Yay! Cool. So as I said earlier, I have. That is the wrong view on this one. Hang on. Side by side mode. There we go. My mistake. So yes, as I was saying at the very beginning of this, it's been surprisingly challenging to find a good tutorial, and this is the one that I finally came across that actually really does break it down from this gentleman from delicioussbrains.com, which is obviously not professional, I guess. But call back to the OMG WTF. Anyway, but he really does walk through the steps to go. So let's just start. All right, let's keep going.
Yeah, let's do it.
Okay, so this was originally designed for local development, so you could run it on your laptop to create the local CA on your laptop, and then be able to do local dev environment with HTTPS. So when you don't see that gross, not secure connection as he shows here, we're going to extrapolate it obviously because we're going to do another machine or multiple machines to do this, but the same principle applies. All right. So this is he has a pretty nice little straightforward example of what a trusted CA is. All browsers have a copy or access to the copy from the operating system verifying root certificate, and that's what CZ was just talking about. Do you want to talk about what a root certificate is real quick?
Do I want to talk about what a root certificate is real quick? I guess I can, yeah. And I'm not an expert in this, okay? So I don't really fully grok the actual like encryption and all of that stuff. But what I do know is that you have two things. You have a key and a certificate. Mm-hmm. And the key is something you should keep private, whereas a certificate is something that can be public, right?
Yes.
And so I will host, let's say this is a website. So before we get into the CA, I'm running a website.
Mm-hmm.
What happens is I provide my key and my certificate to my, say, Apache server, right?
Mm-hmm.
And it will use the key on the server, and it will make the certificate available so that the end user can validate that the certificate matches the key. And that's how you know that the encryption is not being broken, right?
Mm-hmm.
Because the encryption is based on that, what the keys and cert build out. And this is the cryptographic stuff. I don't fully understand how that all works, but basically the certificate and the key are the thing that let you verify that the encryption is safe.
Mm-hmm.
And that's why if you have an unsigned certificate or an expired certificate, you'll get the little red padlock warning thing in your browser, because it knows that there's something not quite right with the certificates and the TLS stream.
Yep.
And then so you bring that back to the CA, and basically when you create a certificate, that certificate is created from a certificate authority. And much like the web server, with the certificate authority, you have the key and the certificate. And the certificate has to be created from the root CA, from a trusted root CA, in order for your browser or whatever to understand it. So there's, in most browsers and operating systems, there's like a dozen or more like trusted root CAs. And these are organizations that have been vetted to stringently make sure that if people create a certificate using their CA, that they are who they say they are.
Back to the VeriSign, right, or GoDaddy.
Right.
Here.
Exactly.
So
and then you can do some stuff like certificate chaining, where you can create like a sub CA, and then you can sign further certificates with that.
Mm-hmm.
But I don't fully understand how that works either.
Yeah, and that's pretty out of scope of what we're doing.
Right. Yeah, and then I guess when you're creating a certificate, you create you have it up already, a certificate signing request.
Yep.
Which is basically what the CA will take that certificate signing request and will, after validating that you are who you say they are, then provide you back a certificate key pair.
And again, you can run this at home. Okay, so let's become a tiny CA, shall we? Open SSL DES3 out Asgard Labs CA.key 2048. Command not found. No open SSL. Well, that's annoying. Excuse me for a moment while I go into this machine and install. I don't know how I don't have OpenSSL on here. That is crazy. Seriously, how do I not have OpenSSL? It's so crazy.
Amateur hour on the Ashgar screen.
Mm-hmm.
Stream. Words.
All right, there we go.
Yeah, how do you
try this?
What is it? Is this some kind of like Fedora box or something?
well, it's a CentOS machine, and I stripped
Yeah.
everything out. But I would think it was OpenSSL would be installed by default. But
well, I mean, not
didn't-
necessarily, because the OpenSSL command is not the same as the OpenSSL libraries, right?
Oh, good point. Good point. DES3 is not a command. Is that? How did I already screw this up? Oh, DES3 cipher commands.
Wait, did you do Gen RSA? Yeah, no, you're not. What do you? Where are you at?
I'm doing this one. The private key.
Yeah, and what's the command?
OpenSSL. Oh, I forgot the ha ha ha. Oh god. Gen RSA. My bad. There we go. Passphrase.
Now, I think DES3 is the encryption methodology. Is that right?
Yes. There we go. And just to, I'm not going to keep this for obvious reasons, so I can show it. But there is our private key. So this is us saying that yes, this is who we say. This is our key to the kingdom. This is all that's important about our good old tiny CA we are creating today. Yep. And if you steal it, you're not a very smart person because there's not going to be attached to it. All right. So now let's generate our root certificate. Open SSL rec x502 new nodes dash key Asgard Labs CA SHA 256 days. So does that mean you have to roll the certs also for your certificate authority? They expire?
Yeah, of course.
So how would you, when you rolled it, does that mean everyone who is taken from that needs to get a new cert at the end of that, that date?
So that, I think, is, I mean, either way, you have like expiries on your regular certificates.
Mm-hmm.
Oh yeah. So your certificates can expire, but the keys don't. So basically, it's up to your browser or your operating system to keep the certificates up to date to make sure that doesn't happen.
Okay. All right. So I walked through all the questions to create the PEM. So let's see our PEM again. Or this time, I guess. And there we go. It is, oops. So it looks a lot like the other key, but it is completely different, which for obvious reasons is what we expect. Cool. And yes, we have our key and our PEM. So now we need to install the root certificate on what we expect. So what I was thinking about doing is I was going to pull this one down to my local Mac here to show how to get it done on my Mac.
Just to keep it simple, you could just cat the file and copy and paste it into a text file.
Cat my Asgard Labs. There we go. Copy.
Now, what's pretty common is, PEM is, I think, the way the binary key is encoded into like ASCII text, right? I believe like a lot of people will, instead of having files .pem that could be a key or a cert, we'll often call them .key or .cert, and that way it's easier to track from the file name which is which.
Okay, so I'm on my laptop now. Security, add trusted.
Well, hang on. What do you want to do? Like, I would say I would put that this certificate somewhere, and then I would first of all we'll get something running, and use like curl, and you can pass in a CA file into the curl as a command line argument, and that way we can verify this without you actually putting it up into your like.
Oh yeah. Okay. Good call.
Yeah.
Good call. Yeah. Okay.
So just save it into a file if you didn't already do that.
All right. So let's create the. Yeah. All right. So how do we want to create the random server we're going to connect to, or pod if we're going to use Kubernetes? What would be the best way to do that?
So what do you want to do? So, well, the first thing we want to do is create our certificate and our key for whatever it is we want, right?
Yes. So we still need to. Yeah.
So you've created your CA. Now we need to use that CA to sign a certificate. Okay. Now, I would say probably our easiest way to use that is to turn it into a Kubernetes secret and attach it to an ingress, right? So what you'll want to do is make sure that your certificate has in its list of DNS names whatever we want to use as our host name for the ingress. So do you have a kube cluster with external DNS set up, or a known name on an ingress endpoint? Oh, we can use zip. We can use zip.io.
Okay.
So have you got a kube cluster?
I'm pretty sure I got one sitting around somewhere. Give me a second to think about where it is. Give me a second.
No worries.
Got any questions in your chat while I'm finding a cluster?
Nope, not yet.
No. Okay. Pretty sure I have a cluster there. Thanks, Aaron. Appreciate that. An old friend of mine just messaged in the chat. JJ, you're the bomb. Nice.
As in you're like exploding, or
I think so. Well? Yeah, I suppose. But yeah, I just constantly explode in front of everyone. Yeah, all right. So okay, get pods. There we go. I should probably get rid of that stuff. Okay, so I got a cluster now connected to. Okay, so what we want to do is we will want to get cluster. Oh. You will have to import your cert though. Just make sure that's very clear. When you create your own CA, you have to import your root CA into the machines that you want to connect to. Like for instance, what you said here in your VMware home lab, yes, you absolutely could take these steps and extrapolate what we're doing and put this in for your VMware vCenter instance, so you don't have that really annoying error that pops up every single time. Okay, sorry. Here is my. What the hell?
So we just want your ingress IP address.
That would be. Is it not here? I thought this is how I found it.
All right. So if you do a kubectl, let me think.
I was just gonna. I guess I could ping this.
Oh yeah, you could just do a host of that, or ping or whatever.
Yeah, here we go.
Yeah.
There you go.
Right. And then so you've used zip.io before, right?
Yeah. Ping
Yeah.
that dot xip.io.
Yeah.
There you go. Isn't there another one? Not just
zip.io.
zip.io.
There's a few.
Yeah.
Yeah. You know, that's a bad habit using ping to do DNS resolution.
Yeah. What would you prefer?
Host? Or yeah, just host.
Yeah. I just, it's yeah. I have bad habits, and you know that. You
I do know that. That is true.
Okay. Where are we? So let's go ahead and generate our out. So I'm assuming it's going to be this guy here. What? There we go. That's not right.
No, what do you?
52. 52. Right?
Hang on, just switch back to.
I was doing this, creating the key.
Yeah.
The private key for that instance, or that IP is XIP. So then we can take that and put that.
Yeah, but that's just the name. So you like, I mean, you can put the IP address in the host name if you want. But
oh, okay.
Like it's not, the name of the file isn't going to affect anything. So to keep things simple, I would just do like my.key and my.cert.
Oh, well, this was me trying to make sure I knew that this was the external one. Right.
Yeah.
I was trying to put everything together. There we go. There's a private key for our instance. So then we'll go ahead and create a new CSR off of this. Open SSL rec new key 52 key out 52 CSR. This will be US, Texas, Austin, Labs, T. A challenge password.
Yeah, I wouldn't worry about it because we're just going to use the CA. Yeah.
Okay.
I mean, being extra secure, you should be using passphrases and stuff along the way. But for this, I don't think we need to.
Okay. So now,
good. He's got alt names in there. I was hoping he would, because I was going to mention that it's no longer considered okay to use the common name as the DNS that's okay. So for the longest time, you would say this is the domain I'm securing by using that domain as the common name. Later, they added alt names, and you can see there's a DNS.1 devdeliciousbrains.com. So that's a list of DNS, and you can also do IP.1 equals IP.2 equals. And that's been a thing for quite a while now. And since they did that, they're now at the point where they're like, you should not have certificates that don't have the alt names. So the recent version of Go, I think 1.5, actually by default does not trust certificates that only have a subject name.
Yeah, interesting.
And that is a thing that's going to trip up a lot of people very shortly, because Kubernetes 1.19 is compiled with that version of Go. And a lot of people that are using like validating webhooks and admission webhook controllers may have only signed with a common name. A great example is, let me think, what's the Open Policy Agents Gatekeeper will auto create certificates for its own webhooks. And if you try and use it on Kubernetes 1.19, it will explode because Kubernetes won't trust that certificate. And I think we'll see a lot of people upgrading their Kubernetes cluster and discovering this when everything stops working. Because computers are terrible.
They really are.
To be fair, it's the people that are terrible.
Yeah. I mean, their heart was in the right place, but the downstream effects of that choice is going to blow up so many people. Okay, so I went ahead and created this extra file, just as he suggested here. I changed out the dev delicious with RXIP.
Yeah, so what I was going to tell you to do is I would actually edit that file.
Okay. Oops. Yep.
And do a IP.1 equals and just do the IP address.
IP.1 equals 521.1.6.5.1.146. Okay.
Right. And then I'm not finished yet. I want you to take the DNS1 line and repeat it. So give me a second copy of that and change it to DNS2. And then do star dot in front of the 52.
Star dot. Oh, I see what you're saying. Oh, nice.
Right? And so this is going to give us a wildcard certificate, which is very useful for ingress, as well as making sure our IP works. So if for whatever reason the DNS is failing us, we'll at least be able to verify off the IP address.
That's clever. I'll give you points for that one.
I'm a clever guy.
Yeah.
You know, if you kept me around on more of your streams, I'd be able to help you out.
Dick.
Wow. You don't want me on this stream for like for language, and that you use it yourself. I'm disappointed in you, JJ.
No.
Your grandmother would be so not proud of you.
Oh no, my grandmother loves me.
I know she does. She loves me too.
Hey.
Not like that. Out of the gutter. We're just buddies. Settle down.
Oh, that's great. That's great. All right. CSR, CA, Asgard Web, CA PEM, CA key.
All right. So this is, what are we doing now? Are we creating the CSR?
No, we've already created the CSR.
We created the CSR.
Yes. I am now actually creating our search.
Okay. So now we're acting as the trusted domain, like the trusted SSL registrar, the one that is verifying that we are who we say we are, and we're signing the request. Yes?
Yes. And this feels like a lot of things to type out for a human to do.
Yes. Yes. And that's why tools like CFSSL and other stuff have become popular.
Cert days 825 SHA-256 ext file .2 that It's very easy. That's 5, 2. There we go. There's our cert.
Nice.
Okay, so let's take this cert, copy it, bring it over here. Paste. And I also need to pull in that other key, don't I? The PEM key for it.
So what you might want to think about doing is actually constructing a secret manifest.
Yes.
And copying them into there.
Yep.
Right.
I'm bringing them over off the remote machine.
Well, don't you want them on the remote machine? Isn't that where you're going to run kubectl and stuff from?
No, I'm running from the kubectl from my laptop, unfortunately.
Oh, okay. Usually we're using the Bastion and we're sharing.
Yeah, the Bastion has all the CA stuff on it. But this machine, I'm logged in the IBM Cloud with.
Gotcha. Okay.
It's an unfortunate setup on my part.
Yeah. And the other thing is you could just be because you want to base 64. You want to base 64 encode them.
Yes.
Yeah.
Okay. So I got the keys on here. So now we need to create a secret manifest, right? So
yeah. And so I would do kubectl create secret, and then do first of all just do help. Nope, -h.
Generic?
Right. Nope, TLS.
TLS.
That's what I was looking for. And then I think you give it a name. Oh, there you go. You give it a cert and key. And then you can also, I think, pass it as CA.
Cert path, cert, and key. And
interesting.
Not seeing the CA.
Yeah, so when you do a Let's Encrypt, it'll actually put the CA cert in there as well, which isn't absolutely necessary, but it does mean that you have that CA in a secret if you need something else to be able to trust it. But we can go ahead and just do the cert and key.
Secret.
Just why don't you copy and paste that line from the top?
Yeah.
Yeah. And just fill in those two paths.
I gotta go back to the name though. Change the name, right? To Asgard Labs, I guess.
-TLS. Just I always like to just end.
Good point.
Yeah.
Yeah, no, I'm with you. This cert is 5. Oh, of course, tab complete doesn't work, you bastard.
Oh, why not? Oh, if you get rid of the equals and just do space and then do it, it'll be fine.
Oh, really?
Yeah.
Oh, cool. This is 5.2.
Cert.
Search. Then I go back and do the equals.
No, you don't need the equals. You can
really?
You can do a space or you can do an equals.
Oh, I didn't know that.
Yeah.
Key.
Yeah.
All right.
And then do -- dry run. Yeah.
That's right.
So that should make sure it's valid. And so what you could do is you could do output it to a file if you didn't want to actually submit this right now to a cluster. So secret dot whatever dot YAML.
Oh, did you need to do --o?
Oh, dash dash.
YAML?
Yeah, you need to do -o YAML. Whoops.
Oh, well, whatever.
I knew we were missing something.
Okay, so that's working there now. So now we can go and spin up a Nginx container,
Yeah.
be able to connect to it
Yeah.
via
So
our
let's,
XIP, and then we can connect the Nginx to the secret, and everything should just kind of fall into place.
yes.
Okay.
So let's
So-
create a namespace.
Okay. TR CA testing. Okay. Create.
Do you have
Oh.
CTX? Can you do NS?
Yep.
Just so you
Don't
don't
think
accidentally
about.
stick things in the wrong place.
Yep.
And so now I would run that. Oh, never mind. You did because you didn't. You took away the dry run, so we're good there. No, just do kubectl create deployment. You don't need a documentation for this.
Deployment.
Right? And you give it a name. And then --image equals Nginx.
Nginx Vitus.
Sure. And then do we need to do something for ports?
That's kind of one reason I was coming over here.
Yeah,
Don't actually
well, just do a -h.
Nope. Oh,
Yeah.
no, we'd have to create a service, though, also, after we do this.
Yeah,
Right?
yeah, you do. But I couldn't remember if the create deployment lets you specify ports, because in a pod template you can have a list of ports. Yeah. So you can go ahead and just hit enter on that create deployment. And now you can do kubectl expose deployment Nginx. And then --port 8080 to 80.
Okay.
I think so. I'll just do actually you're fine. Just do a --port 80. Yeah, that's fine because it'll create a cluster IP and just assign a random.
Yep.
Yeah. So you do a get service. Right, and so now your final step is to create a ingress.
Mm-hmm.
And now this is where I don't remember the syntax, and I don't think. Can you just do a kubectl create ingress for me and just see if they've brought that into kubectl yet? Because they do have a ton of generators.
Looks like it. No.
Well, you got help for create. Scroll up and see what the commands are it accepts.
Nope.
Yeah, okay. Looks like you're going to have to do it the hard way. Dear Google, how do I make an ingress? We nearly got there without having to do docs. Right. So that is without TLS. So let's do it without TLS first. So let's grab that. Hey, did you know that on Ubuntu you don't have to do set paste? That's just the default.
Oh, nice. I mean, I could change it in my vimrc if I really wanted to, but I'm not going to. Service with engine Export number 80, like that.
Yeah, but you're missing something.
Awesome.
We need to provide the host name, right? Because in that ingress, they're doing a path, but you're actually going to be doing it by host name.
Oh, good call.
Do you just do dash host? Keep scrolling.
So.
Path types. Keep scrolling.
Why are you not being nice? Host name. Here we go. Dash host. I guess you're right.
Dash host.
And that's under.
Well, it's in the same as path. So I think. Wait, hang on.
No.
Go back to.
It's above HTTP.
Oh, it's part of the. It's part of the same list that HTTP is. Yep. So you can put it under HTTP. No, you can't. It has to be above or below it.
Yeah.
Never mind.
Oops. That was
zip.io.
This guy. There we go. Like so.
Mm-hmm.
All right. So K apply dash F ingress. What? What?
Is this a matter of the documentation being for the latest version of Ubuntu, for the latest version of Kubernetes, and you not happy?
19. Okay. Get versions.
It's just kubectl version.
Oh. 17.
Well, your server is 18. So do a kubectl get ingress dash capital A.
Kubectl get ingress dash capital A.
Okay. And so just grab any of those. No, you want to do a get on one of those -o YAML and just see what the API version and kind is. -n, you need to grab the namespace.
Damn it. I don't remember what it was.
Can you just scroll up and look?
Yeah, it's this one. What?
No, that's it's the wrong namespace.
Oh. Right, you know. Oh yeah, my bad.
Should be educates-portal.
Yep.
You really need to clean your clusters up a bit.
I do. Well, this cluster's been sitting there. I really do need to blow it out of the water. That didn't work. Let's try Tecton pipelines, I guess. Namespace. That's.
That's because you did it the wrong way around. Yeah, you're doing it the wrong way around.
Just trying to undo it.
Tecton pipelines is the namespace.
Oh, Jesus, really?
Well, just change where the N was. Oh, you make life so hard for yourself.
I really do. I really do. Tecton pipelines. There we go.
All right. And so you're looking for the very top.
Beta 1.
Extensions, yeah. So just if you flip that over. Oh, you know what we should have done?
Hmm.
Do kubectl explain ingress.
Oh, there it is.
Yeah.
Yep, there it is.
Yeah. It would have been easier. That's right. We got
so
there.
much easier.
So
God.
now apply that
Sure.
guy.
Making me type so much. What?
Uh-oh. Unknown field service.
What?
Jeez.
It just hates us, doesn't it? Backend server. That should be normal.
All right. How do we get to yeah? All right.
Service name. God damn it.
There's. Oh yeah. So they changed the API.
Yep.
So on the back end, it goes straight to service name and service port.
Backend. Yep.
And drop it back to indents as well.
Yep. That
Sure.
paths, host, path. Don't care about that. That looks right. Okay.
Yeah.
Huzzah!
All right. So now you should be able to curl that IP address or the host name, sorry. And you should get your default
Huzzah!
welcome. Cool. So now in the Ingress Research doc, search for TLS.
My little clapping just went off. Hopefully people heard it on the stream, but we didn't actually hear it in our ears because I screwed up our sound.
Why are you breaking the fourth wall?
TLS. What? I figure out something wrong here? No, I did. TLS.
All right, so it's telling us about the secret, and we already have that.
Here we go. That's it.
Yep.
You know what? Actually, I'm going to do copy ingress to ingress TLS and ingress TLS. Nothing change anything else, but add the spec of TLS hosts. That guy with
That host is a list.
oh, it is not.
You can just put square brackets around it.
No.
That works too.
Oh, that's.
I think the dash should be under the S.
Oh, yep. All right, I'll figure it out in a second. Secret name of Asgard Labs TLS.
Yep.
Okay.
That looks right.
All right. Let's overwrite it. There we go. That came back like we expected to, but now we should be able to go to HTTPS.
Yep.
Right?
All right. So that's good.
So, yes.
Right? This is telling us that we don't trust the CA
Yes,
that the certificate was signed with.
Yes. But
so now what you can do is do a curl-k. And so that's just telling it to, I don't care.
Mm-hmm.
Right?
Mm-hmm.
And so that's telling us that it's working. So Did it actually work? Okay, yes, good.
Yes.
So now it's, I think, curl-ca file. Do a curl-h. Look right at the top in the C's.
CA cert.
CA cert, yep. So if you...
And again, that's our PEM, right? CA
Yeah,
PEM.
yeah. So that's why I like to always, even for the CA, I always like to call it key insert, just to remind myself which is which.
Okay.
It was CA file, dude.
Thanks.
Wasn't it?
Yeah, you're right. What?
Wait, was it CA cert? Am I?
CA cert.
Oh my God. I led you astray.
It's fine.
But
We're all learning.
you misspelt PEM anyway, so it still would have gone wrong.
Oh, story of my life here. PEM. Hey!
Hey, that's good.
Yeah, that worked. Pretty cool.
Yeah.
So we successfully created our own CA.
Yep.
Pulled out a CSR, requested it, created a pod on Kubernetes, and then actually injected our secret into it and then validated against it. And it came back exactly how we wanted to.
Yep. Now do me a favor
Mm-hmm.
and do that same curl against it, but without just the host name.
Just the host name.
Yeah, just the IP address, sorry.
Oh. Like this?
Yeah.
Nope.
Oh, no, that's going to fail because do a kubectl edit on your ingress. Or just actually edit your ingress-tls. Let's mess with it locally. So under hosts, add 2 more. And the first one, do just the IP address. And the second one, do like food at dot, right? And then wait, you need to duplicate the rules.
Oh, okay.
So just
the whole thing?
like, no, well, just the list. You don't want to do rules again. So starting from the dash where you are yet. Yeah. Just the IP.
No.
Oh, must be a DNS name, not an. Okay. Well, in that case, let's get rid of the IP address. But at least we'll be verifying that the wildcard works.
Huzzah!
Nice.
There we go. That was pretty cool, man.
Yeah.
That was pretty cool. Well, yeah. I dare say we got everything we wanted done.
Well, how are we looking time-wise? Do you want to maybe now look what it's like to do the same thing with Cert Manager?
Sure. Yeah.
All right.
If
do
we
you
want to walk through.
Do you have Cert Manager installed? I saw you've got a lot of garbage already installed on this cluster.
No,
do
I
a
probably don't.
kubectl explain certificate.
Nope.
No. Huh. I was sure you were going to have Cert Manager. All right. Let's do it.
No, come on, really? All right.
Yeah. Now, do you want to do easy mode?
Well, so already, I've promised myself I will be using Cert Manager a lot more recently,
Okay.
but everything, like, because I don't use them on a daily basis by any standard, I always have to relearn everything every time I use it.
All right.
So,
So
I'm sure.
what I want you to do, and I think this
Mhm.
will help you, is I want you to open up a new browser tab and go to tech.paulcz.net/blog. And then scroll right near the bottom, creating self-signed certificates in Kubernetes. Right, now scroll down, blah, 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 talking garbage, scroll down. I want to get the second section, scroll down. Actually, let's start from the top. It won't take us long. All right, so we already have a kube cluster, so we can skip past that. So start with the create namespace sandbox. No, you already did that. Yep.
All right.
Right. And then, so you can see I'm creating a cluster, an issuer, right?
Yes.
So an issuer is a thing that Cert Manager uses to issue certificates. And you can see in my spec, it's set to self-signed. And so go ahead and run that command.
Could we, in theory, use one of our certs that we created here instead of self-signed?
We could. And I'll show you that in the next section.
Okay.
Now we can do the next one. So that's the issuer. And then we create a certificate using that issuer. So you can see the next one. We've got the DNS names, and we're using issuer ref of self-signed. Yeah. So paste that. Okay. And then you can do a kubectl get certificate.
There you go.
Right, and so that's saying there's a certificate there. And so now I think the next command I'm telling you to do a get secret. Yeah. So if you do run that again and do a -o YAML, now scroll up.
There's some secrets.
You'll see there's three things: a cert, a CA cert, a TLS cert, and a TLS key.
Right? Nice.
And it provides that CA cert so that if you need to provide that to something else to trust it, you have it.
Nice.
Yeah.
Nice.
So now we've done that. I think I have a command to even verify.
Test the cert is valid.
Yeah. So what we're doing here is basically getting the certificate and passing it through OpenSSL and just validating that it's a real certificate.
That looks like it's okay. Right. And that's what we saw with DNS right there.
Yeah. So now we could use that to sign we could use that as part of an ingress, right?
Nice.
Nice. And that was super quick, right?
It really was.
Now, if you want to do something to use your own root CA, if you look at the next section of the blog post, creating multiple certificates from the same self-signed CA with Cert Manager. So what we're doing, if you scroll down a little bit, is we're creating a self-signed certificate, a issuer, and then we're creating a certificate, and you can see we've got is CA true? And so that creates this as a CA type of certificate. So what you should be able to do is the CA key and cert that you created before. Oh, you created did you do a passphrase on your key?
I did. Yeah, I did.
I wonder how Cert Manager will deal with this. You know, let's step through these steps, and then we'll see if we can apply it to your thing.
Okay, so the new namespace.
So we're creating a new namespace, Sandbox 2.
Okay. And then we create our self-sign homeboy again, issuer again. Okay, makes sense. Then we come along with this guy.
So this is creating our CA.
We don't have to change anything here yet.
Nope.
Okay. All right.
Right, and then you can see the next step is to create a new issuer. And you can see we're passing in the secret name that we just created.
Yes. Okay.
Right. And so you've done that. And now we are going to create a certificate using that CA.
Which is this one right here.
This one right here, yeah. I think you missed the last line.
Okay.
Yep. And so now we're just going to check that the certificates and secrets exist.
You got CA server, but not, oh, the client was the second one. Okay. Let's go ahead and create.
Wait, did we not create a client?
Yeah, we didn't create the client. The second one.
That. Yeah.
There we go. Now, that's more like it.
Right.
So then we should be able to go and verify here.
So this is this is kind of an interesting set of command lines, because you see I'm specifying CA file, but I'm not actually specifying a file. I'm specifying a command line.
Oh, you're doing it through the
yeah. So
output.
if you use if you put a command in parentheses and put that little less than sign there, that'll treat the output of that as a file.
Yeah.
And so that's letting me grab. I think you grabbed the output as well.
Oh, I did.
Yeah. So that last line was the output.
Clever.
Right. So that's making sure that the certificate is signed with that CA. And then
this one?
Yep.
Make sure that the
right. So both of those certificates are signed with that CA. But if you go back to where we created the certificates, you can see under usages, we have server auth and client auth. So if you go down to the next test, we can actually use these not just as certificates for the encrypted TLS encryption, but we can actually use them as like authentication. Right? So you can see I run an OpenSSL server, and I grab the certificate key and CA file from the server. Right? So go ahead and run that. And so that's effectively, whoa. Oh, I wonder if this is a, oh no, that's okay. Sorry, it's fine. It's backgrounded. Yes, we're all good. So we've effectively created a really dumb web server.
Yeah. On port 1.
And so now we're going to make a really dumb request.
There we go. 200.
Right. So we get a 200. But if you would have done just like a HTTPS request to this, you'd get an unauthorized. So if you maybe do a curl HTTPS localhost 12345.
Yep. Nice.
Well, hang on. This is unable to verify the legitimacy of the server and therefore cannot. So do a -K. I wonder how that'll affect it. I think it'll still fail. I'm not sure why it's saying it didn't. But so this is because it's not just the TLS encryption, but it's also ensuring that this cert is being used to authenticate against the server and vice versa.
Yep.
Yeah.
And that's the reason why this can work, because we're forcing it in here from the actual server. Yep. That makes sense.
Yeah, and notice we're using the client secret here, and we were using the server secret in the other one.
That's
so you go ahead.
Clever.
You can go ahead and foreground and delete the background, or you could have done what is it, kill %1?
I think that's right.
Yeah.
The foreground did it for me, right? FG?
Yeah, it did. Now, if you wanted to wrap this up by turning your CA into a Cert Manager thing, we can try that. I'm not sure how it's going to deal with the passphrase, but it might be interesting to figure that out. So what you want is you need your CA key as well as your certificate.
So there is my PEM right there. So I need EBI, labs, key, so paste, come back here, that labs key. All right, there it is.
Mm-hmm. Now, what we might need to do is do a kubectl get secrets sandbox 2. And then we want to get that CA TLS and -O YAML. And then I want you to look at let's actually just stick it in a file. So just like, ca.yaml or something. No, we're going to create a new CA out of it. We're just using this as a, so go ahead and edit it. And then just empty out the CA cert and TLS cert.
This is base64 encoded too, isn't it?
Yeah.
Okay.
Yeah. So I think when you're doing this, you actually put the CA cert in twice, once as the CA cert, once as the TLS cert. So do a cat of your CA cert and pass it to base64 encode. .pem. It's just base64, isn't it?
Yeah.
And then you don't have to do a -W. That's right. That's a Linux thing. Yeah. And so edit the new secret.
So this one is the cert.
You want to put it in both cert locations. Yeah.
And then do the same thing with the
key. Right. And then we probably want to like clear out the annotations.
All of them?
Yeah, I don't think we need those because that's all because it was created by Cert Manager. Get rid of the created timestamp, all the managed fields. And you want to get rid of the annotations line as well. There's nothing in there. Yeah, get rid of all the way down to name. Yep. And then give it a different name. asgarlabs.ca or whatever.
Mm-hmm.
And then probably change the namespace.
To what?
Whatever namespace you want to create. All right. And then get rid of the resource version self-link. UID. Yeah. Perfect. So now kubectl apply that. Do you need to create that namespace?
Yes.
Maybe NS into that as well, just so you. Yeah.
Okay.
Right. So now we need to create a issuer. So go back to the blog where we were creating the issuers, and we'll find the block of text we need. So scroll up a little bit further. That guy right there.
You gotta change then.
Yeah. So just create a file. In fact, just edit the ca.yaml and stick it in that as a second YAML document. And yeah, obviously get rid of the garbage. And then, yeah.
And the next one.
That's it.
That's it? Not
So
doing it good.
Well, I just want to make sure this works, right?
Okay. Yep.
So do a kubectl get issuer. Yeah, do a kubectl describe issuer. See, it's not ready, and I think it's not ready because it's going to be mad about the.
Oh, yep, there it is. Parsing the key. No, that's not the same error.
Tags don't match. But I don't know if that's because it can't open the key because it's got a passphrase. Let's look at the Cert Manager docs and see if they have any way of dealing with passphrases. What do we want to look for?
Yeah, passphrase.
Is it pass key? I'm trying to remember what it asked for. Let me see. What have they got under API reference docs? Let's look through there.
Oops.
Resource types, issuer. All right, string kind spec. You just. But where
was it?
Scroll back up. You lost where we were when you resized it.
Ah, okay.
Issuer. Okay. All right, click on the issuer spec. Issuer config.
Doesn't look like it's.
Click on self-signed issuer. Oh, hang on. No, what did we provide? CA? Go back one. CA issuer, yeah. All right, maybe Google for Cert Manager CA issuer passphrase. Yeah, that's got nothing to do. What when you created it, did it ask for passphrase or password? What was the actual thing it asked for?
Don't remember. Should be.
Passphrase.
Passphrase, you saw?
Looks like a passphrase.
2 words. Is that right?
I'm not seeing it. Maybe quote passphrase. Yeah. There we go.
Yeah, it looks like a problem.
Something about it. Oh, experimental. Ooh.
You put in base 64 encoded password into the values YAML here.
Okay, so hang on. Let me see. In the values.yaml. Oh, I see. He's creating a secret. And in the data. Okay, so scroll back up a little bit. Scroll back up a little bit. So grab that experimental PKS key store password line and just stick that into Google. Scroll back up. Scroll back up. Click on the release notes as well. And we'll see what the, all right, so start with the commit. And then look for where he's updated the docs and the files changed.
You didn't.
Really?
Release notes
Okay,
here,
well,
though.
okay, so what kind of key store password did we use? It doesn't say. I think the second one, the one we were looking at looked right.
Yeah.
The next release. Oh, see, they're looking at it as an output from certificate resources. I wonder if that's, all right, so right click and open that in a new tab, see what that's going to, the JKS, yeah. Ah, okay, so yeah, so the PEM is the one we want. So scroll down. Scroll down. Okay, I think that's the one we were just in. All right, so go back to the next tab to the right. And so it looks like it wants to only write if key has actually changed. So where does it look like it's getting the password from?
This is the sync. Key store is, like, I'm assuming, the object that actually stores the cert. Right?
Is the name of the, is the name of the data entry in the secret resource used to store the, okay, so keystore.p12.
That's a Java thing.
Oh, that's the P12 file. So we just want to provide the password.
We want to provide the PEM, and then when it reads it, it asks for the password.
Right.
And we want to inject that password in, but we'll say right now that's not capable of doing.
Right.
That's how I'm reading this.
Yep, I think you're right. Well, maybe we should just call it where we're at then.
Yeah, I think so.
I feel like this could be a fairly deep rabbit hole if we tried to keep going.
Yeah, it seems reasonable, but we succeeded, right?
We did.
We succeeded. If anything, that is a great sign of us coming back together and streaming, right?
Yeah.
We actually got it actually done.
Yeah, we got a bunch done.
Yeah. And if you are just catching on to us right now, I am going to be pushing this up to YouTube, where we actually did truly start from the very beginning of creating our own CA, and then authenticating against the different certs. So I had some conversations in my chat about using vCenter, being able to put the same thing on vCenter and be able to have your CA inside of vCenter, and then externally authenticating to your vCenter through that CA that's already on your vCenter, which is kind of cool if you think about it. Which is a really neat way of thinking about it, because now you don't have that stupid little warning that shows up every time you get on there. And,
yeah, that's right. I mean, yeah, because there's a lot of stuff like that, like not just vCenter, but like you think about all your like your old Dell like iDRAC cards, right? They were all signed with a random. So having something that could go and actually provide real certificates to those. Well, Calvin's the password, yeah.
Yeah.
yeah, root Calvin.
There you go.
Yeah, I worked somewhere, and whoever did the initial setup thought they were really clever because they changed the password of them all to Hobbs. And I'm
nice.
like, you know what? That's probably going to be anyone's next guess. So I don't think you're that clever.
It's good. It's good.
Yeah.
Nice. All right, sir. You want to say goodbye?
Yeah, good stuff. I will see you before next Thursday, but hopefully next Thursday we can stream again.
Seems as of this exact moment in time, yes.
Sounds good.
But we'll see where it goes. All right. Thanks, everybody.
All right. Bye.